First part is to talk about your endo and exo term. You remember about that? Okay. So a lot of times you all don't quite know how to differentiate exo and endo. Moreover, this question a bit the GG because the question did not even give you a table and show you the before and after temperature. Like you wouldn't know, like without number, how would you? So this is the one you have to memorize. Do you remember what is this? When you see ammonium chloride and water, anybody? Endo or exo, if you could remember. So this is a bit that you have to memorize, law. So memorize now with me, law. Ammonium chloride with water should be. Oh, correct. Endo. Yeah. So we have two. We have endo and we have exo. So endo is to release heat. Okay. Exo. What am I doing? Sorry. Exo is to release heat. Endo is to absorb heat. Okay. So correct for Nicholas and Rian. So ammonium chloride belongs to endo, that is to absorb heat from the environment. So when I say environment, it basically means the water. The water is the surrounding and the environment. Okay, so since water is the surrounding or the environment, means the water temperature will drop because absorb. When the powder get into the water or the liquid, or the water in this case, the powder absorbs heat from the environment. The environment is the water already. A lot of people mistaken this, then you won't get it correct. You will answer the other way around because you thought surrounding is outside. So absorb from surrounding means outside temperature go down, inside temperature go up, then you GGL. You answer the other way around, your whole question wrong. 4 marks, 5 marks gone. Very dangerous question. Okay, I repeat, water is the surrounding. Whenever we ask about thermometer reading, it's always talking about the water, which is the surrounding already. Okay, so like first one, predict the observation that can be obtained from this study. Okay, predict observation that can be obtained from this study. Observation means what you see. Now, the thing is, we don't even have the table to help you. You have to kind of imagine yourself. So what happened would be probably this one law, thermometer law. So I'm talking about whether temperature go down or go up lah. That's what question is asking for. Okay, so obviously this is endo. We have already talked about it. That should be temperature go down. Temperature decrease. Okay, so you can write the temperature reading decreases. Okay, temperature reading decreases. There you go. That's it. That's what you can see. Imagine if you you have a table, you should have like a before and after temperature. Then you can see like maybe, I don't know, like 32 become 28 Celsius. But decrease but no table, my friends, sometimes. Very sad. Okay, number 2. Explain why decrease for absorb. I absorb from environment, but decrease. You understand? So this is to explain the absorb or release part of the experiment. So this is about absorb. Okay, so you can write the heat is absorbed from the environment or from the surrounding matter. Okay, the heat is absorbed from the surrounding. If you're wondering what's the other name for, what's the other chemical for exo that I have to memorize? Okay, so for endo, you memorize this one, ammonium chloride. For exo, it will be hydroxide, sodium. Okay, any hydroxide thingy it should work. Exo means release heat, means temperature increase. Okay, ammonium. You look for the word ammonium, then endo. For exo, you look for the word hydroxide. I hope that helps for you to memorize. Okay. So state a type of reaction like endo. We already discussed about it. So please write that. Endothermic reaction. Must write the word reaction now. Okay, state the responding variable. I imagine you have table, remember? It should be on the right side of the table. So I guess that should be the reading of thermometer. Okay, so reading of thermometer. Or the temperature changes before and after also can, because before is 32, after is 28, maybe. I don't know, I'm just guessing it. So yeah, you can do reading of thermometer or temperature changes before and after the experiment. Okay. Yay, there you go. That's the first kind of topic we have endo and exo. It could be exo sometimes. Okay, all good, everybody? Okay, let's move on to the next one. So after this, we have what? We have after endo exo, we have Haber process. Haber, you have to memorize one. You turn the your notes again and find out. Okay, memorize Haber process like nitrogen, hydrogen, temperature, how many, atmospheric pressure, how many. Those are fixed one. It's like making cake. There's no question one. I mean, you ask, why must use flour? Huh? Ingredient, you know, why must use the egg like that? Why must just follow and you will make a good cake or bread. So Haber works the same, just memorize the steps and memorize the ingredient and the temperature and all that. I don't have that question here, sorry. So after that, it goes into this topic where you have your reactivity series of metal, remember, for reaction with water, reaction with acid, and reaction with oxygen. There's three types of water, acid, oxygen. So this one obviously is acid, obvious, okay? You remember the sequence of metal? No, not yet? Luckily, you all see me now, okay? So sequence of reactivity series of metal, everybody. Please stop calling me a zebra in the library. Call me sexy girl. No. I'm a boy, so I would say it, but I make this in Mandarin. So it's 帅哥, call me 帅哥. 帅哥 means handsome boy, handsome guy. Or if you're a girl, you can say sexy girl. It's okay. It's okay calling me a cute zebra. I like call smart guy. Huh? What? Calling me, it's okay to call me a cute zebra. I like call smart guy. Or you want smart guy, is it? Up to you. Okay. So up to whichever you want. As funny as Jahan's one. What's Jahan's one? Similar. I forgot what's his one. He told me before, but I forgot. I think similar, but the ending different a bit. Is it? Okay, so yeah, there you go. That's basically how you remember them. Okay. Or in Malay, oh yeah, you got in Malay. The one is different. Kalau nak kahwin, mesti ada zakah besar, something like that, right? Is that in the BM version? I heard before. I forgot. Okay. So yeah, because in BM the name all starting different already. Kalau nak kahwin mesti ada zakah, something like that. So okay, right. Now this is with acids. So do you remember what gas is produced when metal reacts with acid? Do you remember the name of the gas? If you remember the equation, then you remember the name of the gas. Anybody? So when acid reacts with metal, it releases carbon? No. It releases a very dangerous gas. Start with H, so obvious already, right? Okay, hydrogen. There you go. Hydrogen. Okay. I think I have the yeah, there you go. Then this one you remember? We memorized together one. Okay. With acid, metal with acid produces hydrogen gas. Hydrogen gas. Water also produces hydrogen gas. There's only hydrogen gas. There's no other stuff. Don't bother about carbon, don't bother about oxygen and whatnot. We only produce hydrogen gas. For oxygen gas reaction with the metal, it becomes oxides. Yeah. Okay, so this is hydrogen gas, by the way, just to mention. Okay, inference, everybody. Inference means observation. Observation plus reason. Okay, so the sad part is we don't have the table also. No table, how? So we have to think about it. What's your observation? So take a look at the picture. A very obvious observation here is this one obviously has more bubbles. This one has lesser bubbles, isn't it? That's your observation. So then, since we have two, usually we do comparison. So your observation is P more bubble, Q less bubble. Then because why? More bubble means what? More bubble means the metal must be more reactive. That's why it produces more bubble. So I want you to try to form your own sentence. I give you the guidance. So first you must say metal P more bubble in a proper English way. Q lesser because metal P is more reactive than metal Q. Can you do that? Try. Okay, can. So metal P releases more gas bubbles. Okay, releases more gas bubbles than Q because metal P is more reactive than metal Q. That's right. Less bubble, there is less bubble in metal P because it's more reactive than metal Q. Emilia, it's better to do a full sentence for comparison. That means you must say both sides. That means you can do like that. So you can write there is more, but your concept correct lah, your answer correct, but you have to do a proper sentence. So there is more gas bubbles released by metal P than Q because metal P is more reactive than Q. Just to let you check, yeah. Okay. All right, that's a proper way of writing your inference. Again, just to remind you. Okay, question B, shall we? State one responding verbal. Okay, again, no table. A bit sad today, no table, keep on no table. Okay, if there is table, I believe we could actually have a table of volume of gas bubble, right? Or even so, we can actually count the number. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. You can count, so there will be the number of bubbles. Or amount, yes, can amount of gas bubble. Okay, also can, yeah, number of gas bubbles or amount of gas bubbles. Okay, it actually also means reactivity of metal, right? More bubble means more reactive, so you can do that as well, slash for another answer. Reactivity of metals. More bubbles means more crazy, more higher reactivity in the higher part. So P must be like higher part, Q must be like maybe middle or lower part. Okay, right. C, everybody. Okay, a new metal, metal R, as you can see, set case, there's only 3 bubbles, so set. Okay, so this must be an even lousier metal. So please arrange the metal in ascending order of reactivity. Okay, ascending basically means increasing. So your ascending, you should start with the lousy one. Okay, everybody, start with the lousy one with your alphabet to the better one or the highest one. Very easy, no problem. RQP. Okay, operational definition of reactive metals. Operational definition is responding variable. Reactive metal is your subject. So start off with your subject. Okay. Now, we all been doing this for so many weeks. Almost every week we must do one question like that. And you know, probably you should already know what I want to tell you the next. What is a reactive metal? Like how you answer, use your responding, make sure it relates to what you can see, which is here. Okay, responding. Okay, you try. Okay, you try. So a reactive metal is not a process, right? It's not a substance. We will be specific. It's a metal, by the way. Reactive metal is a metal. So it's answering like, what do you mean by reactive metal? What is reactive metal? So for people who don't learn science, you cannot explain in a very scientific way. You have to explain what the person can see. What is reactive metal? Look at the bubble. The bubble got more bubble. Reactive, no bubble. Reactive. Don't ask ready lah. Okay. So like very like you don't want to explain in detail. You just want to be as childish as surface as possible. Nicholas, very good example, but you lack of one very important word. Reactive metal is a metal that reacts with, hey, no, actually not water, by the way, bro. Is this water? It's acid. Uh-oh. Okay, so other than changing your acid, you have to also add one more word. Okay. I typed mine for you, so for your refer. Reactive metal is a metal, okay, that releases more. Do you have that? More. You must add the word more. Reactive metal is a metal that releases more gas bubbles. Okay, releases more gas bubbles when reacting with acids. Okay, it's a metal that releases more gas bubbles when reacting with. See, very straightforward one, very short only actually. So Nicholas, it's acid, by the way. Can I write reactive metals form different amount of gases according to its position? Oh, no, Iman, your answer, it's not specific. That's very general, which we don't want. Operation, we want to be as straightforward, as specific as possible. So I'm telling the little kid, I'm answering that kid as, look at the bubble, more bubble than more reactive. Someone being specific with acid, you know. Okay lah, Nicholas, no problem. You're almost there already. You just have to change the water. That's careless mistake actually, not that you don't know. So change water to acid and then add the word more. Is everyone okay? I mean, I could tell you there's at least one question or max two. You know, it's not like super important. Even you lose this 1 mark, then I lose 1 mark, right? Nothing to be said about also, but it's 1 mark, you know. Sometimes it could be 2, so I don't know, like how should I put this? Like I say, like you die must know how to do, like cannot it's not like very easy also. So you all try like at least you all got 1 mark. Okay, all good, everybody. Let's go to number 3, which is with oxygen experiment. Okay, the one and only experiment where the test tube horizontal one is very obvious. Okay, so we have potassium manganate 7. Potassium manganate is the one that releases oxygen and then reacts with the metal powder. Then they burn. Maybe got fire, maybe no fire, maybe got very bright, maybe not very bright. The results are given below. By reading the description, you already know who crazy, who not crazy, right? Okay, so like number 1, hypothesis. Okay, you know what? I always don't want to risk my answer, so I would skip that and I would go straight into my variables first, so I could go back with a more accurate answer. Let's skip that. So what is fixed variable? Something here must be fair. No matter you use X, Y, or Z, something here must be fair, right? So that will be your constant variable. Now, metal powder must use the correct adjective law. It's not number, it's not volume, okay? Powder, so small one, usually we say quantity or amount or mass of metal powder, okay? So don't go for volume, don't go for weight, don't go for number, okay? So amount of metal powder or quantity of metal powder or the mass of metal powder. Can write temperature of fire. Oh, no. Not important. It doesn't make much of difference actually. Because we in science tech we confirm you Bunsen burner. Bunsen burner fixed already one. There's no temperature or different fire for you to control. So that's really not to, that's not going to affect a lot. But the amount of metal is going to affect a lot. So we write priority first, the first most important thing to be fair. Okay? Can? You know, the meaning of this is like, okay, like running competition, like 100-meter running, sprint. Something must be fair and fixed between all the peserta. Not the what type of shoe you wear, not what kind of clothing nice or not nice, or how long, how short your sports pants is. The more important thing, a priority to be fair for the competition is everyone start at the same line. Of course, shoe does make a difference. The kind of clothing you wear does make a difference. You know, the most important thing is all start at the same line, all must be same category. L1 means L1, all Form 5. Cannot Form 5 run with Form 1. You might lose because Form 1 faster, smaller, lighter. No, joking. So, yeah, I hope you understand how to prioritize your fixed variable, okay? So, responding. Got table but no use. How to copy? Cannot write the word result, right? So I think this means how crazy they are. So that basically means reactivity of metals. Okay, reactivity of metals. Alrighty. Okay, manipulated variable. So easy. We have different kind of metals. So type of metal powder. Type of metal powder. Okay, after this, since we have responding and manipulated, somehow our hypothesis require both of these to form. There's usually a few methods to talk about, right? I usually ask you to do the. But this one a bit cannot the. The more the more reactive the metal, the brighter the. It doesn't work exactly like that, right? In this case of X, Y, and Z, what I'm trying to prove to the world is I want to tell you that X is crazy. Y and Z is less crazy. So my hypothesis here, I would rather don't go for a the sentence. I will go for the straightforward one, the compare sentence. Like, okay, this is best. This is the highest. This is the tallest. This is the most suitable temperature. You know, I will go for like the most. Yeah. So in this case, my hypothesis will be metal X is the most reactive metal. Okay. Metal X is the most reactive metal, or metal X is more reactive than Y and Z. Up to you. Okay. All right. Okay, so well, this is, I don't think it's a word, I don't think it's a chemical equation because we don't learn chemical. Word equation is writing words. Chemicals is in chemistry. We don't do that. Of metal with oxygen. Okay. Okay, I'm just gonna do one, then the rest you'll do later. It's very simple. But no name, we will just use the word metal XYZ. So let's say metal X plus oxygen. Okay, arrow metal X oxide, like that. Yeah, just follow what we have. That's right, Amelia. So you'll do the same for the rest. Same answer, just copy it. Okay. Arrange reactivity series in descending order. Okay, according to XYZ, descending. Descending means starting from reactive to not reactive. Going down. Descending. Okay, writing XYZ for yourself. Okay. Okay, and E, please write down the names also. Very easy. So if you all don't know please stop calling me a zebra, maybe not accurate but if you know that clearly, you're more confident in answering. So then this makes it very easy for you. So just now, okay, X, Y, Z, X, Y, Z, starting from reactive to non-reactive. And for this one, X should be reactive, so should be magnesium, okay, and Y should be aluminium, and Z should be copper. Easy cheesy. Okay, no problem. Okay. After oxygen, I don't have water experiment here, unfortunately. This is acid again. For you try. I'm gonna skip quite a lot, so I will just do one type with you. This is acid also. Hydrogen gas, you all know already one lah. Okay. This is oxygen again, but asking for different things, I guess. Okay, so I guess we go for electroplating topics. So please turn with me to question 7, page 25. Question 7, page 25. Okay, now electroplating has some very basic rules and regulations to follow. First thing first, battery, everyone. The long side is positive, the short side is negative. Shouldn't be a problem. You should know this already. So then the long side should connect to positive, which is called the anode, and the negative side should connect to the cathode. Is that okay? So this is electroplating. We would use a metal P to electroplate onto the spoon. So the metal that you're going to choose must be the same as the electrolyte, the liquid inside called the electrolyte. So my hint is here. My electrolyte is copper sulfate solution. Then I know my metal must be copper. That's the rule, you all understand or not? Must use the same thing, copper then copper. Okay, so the metal must be anode, copper must be anode, the spoon or the badge or the ring or the whatever you electroplate, the key must be cathode. That's the rules and regulation you must remember. Okay, so there you go. Question number 1, everybody. Please write down the part P and Q, as in the. No, not asking for the metal and the spoon. Who don't know there's a spoon? Asking for there for that one. There the anode and cathode. Okay, so P is anode, Q is cathode. Okay, what happened to the mass of the iron spoon after 30 minutes? So when you start the experiment, this one will dissolve, become smaller and smaller, then the spoon will become fatter and fatter. Okay, so question is just asking for mass. So we just have to talk about the mass. So obviously become fatter and fatter. So the mass of iron spoon increases. Okay, the mass of iron spoon increases. Okay, what is P made of? Your hint is here. So copper liquid, right? Copper solution, right? So the metal must be copper also. That's the rule and regulation you must follow, right? So your answer is copper. If change, then you change. Sometimes question give you this one, sometimes question give you silver. Then they ask, what is this? Don't know, don't have. Then you might write silver sulfate solution. Just change the metal, the sulfate solution, use the same one. Okay, we're not going to change. Okay, so answer is copper. Okay, next one. What observation can be made of P? P is this one. What can you see? So just now I was saying this will become like thinner and thinner. Loses mass. So I think we had this also. Electrolysis is here. Okay, what happened to P? P is the anode. There you go. You can copy exactly this one. Okay, the copper plate dissolves slowly and loses mass. Okay, all good. Alrighty, so that's the observation for, if they ask observation for the P, metal P, you do for cathode. Sorry, the spoon, sorry, I mean, then you do this one. Okay, coated with a layer of copper. If it's another metal, then you change that. So, next one, write down the reason why concentration of sulfate solution does not change. Okay, the electrolyte no change one. See this? Okay, but question is asking why. Okay, which we don't have there. So why? Very easy. Because the liquid, right, it's just a middle person. Imagine if I were to middle person, right? If someone give me something, ask me to pass to the next person, I pass. I'm not supposed to take anything from it. I'm not supposed to add on anything from it. My job is to pass on. So the amount of copper that go into the liquid is equals to the amount that goes to the spoon. I am no one to take anything from them. So that's the meaning. I mean, that's the answer for the question. So how can we form sentence? This is how you can write. Okay, I may type to you the amount of copper ion dissolved in the solute in the electrolyte is equals to the amount of copper ion deposited onto the spoon. Everybody in your chat box, the amount of copper ion dissolved in the electrolyte is equals to the amount of copper ion deposited stick to the spoon. Okay, when they dissolve already, they become ion. Ion means got charge. Got charge. Okay, that's how they attract because of the charge. Okay, question donkey, shall we? Give one condition that iron spoon is able to be electroplated. Nice. You want nice, Okay, like nice, number 5. I want nice. Oh, the must use small current. Oh, the spoon must be rotated frequently. You choose, up to you. We have 4 answers for you, but you answer accordingly. What question wants? Okay. Yep, that's basically what electroplating is about. All good so far. Okay, I'm gonna pick another question. Electroplating done. This is another electroplating which I'll leave it for you. Okay, question 9. Question 9, page 27. Purification, we have 3 by the way. We have 3 electroplating. Number 1, we have 3 electrolysis. Number 1, electroplating. Number 2 is the aluminium one, this one. This one. I'm pretty sure you know this picture. Okay, aluminium one. And we have a purification method, which is what you're looking at now. Okay, so well, same. The rules and regulation. First thing first, you have impure and pure. Impure must always to become the anode on the left side, and pure must always become the cathode on the right side. Okay, and the liquid that you use, or I should say the electrolyte that you use, must be the same metal. See, I'm playing with silver, right? If you're playing with silver now, then this should be silver blah blah blah. Silver nitrate solution, for example. So if you change, then everything has to change also. Okay, state the error causes no observation. Oh, something is wrong here. Do you realize something is weird? Something that you have not seen before? That causes no observation. That means after you turn on already, you realize that, hey, nothing happened. Why like that? Something is not placed correctly. So what is that is wrong here from the picture? Do you realize that? Don't have something or something missing. What the heck is this? Like, is this like a wave or so? Missing battery. Yes, correct. Missing dry cell, actually we call it in science. So you kind of have to draw the whole thing again to show the correct part, but you know, it's okay for now, just being lazy and not waste time. So you draw battery, long shot, then you continue the rest when you want to lah. Okay, you do the rest. Okay, but that's the battery thingy. Okay, right, like, please write down who is anode and who is cathode. Next question, very simple, this one. Asking for the impure and pure. Remember the rules and regulation I mentioned just now? Anode must be impure. Okay, cathode must be pure. Memang like that one. So anode is impure silver, cathode is pure silver. Okay. Alrighty, next one. Right observation. Okay. So anode will become thinner and thinner. Cathode will become fatter and fatter because all the silver has gone over lah. Okay. But we can refer to this. Do we have that? Nah, this is the result like that. It looks like that. One skinny, one fat. Okay. Ta-da! Can copy exactly? Oh, cannot. It's a copper. You must change to silver. Okay. Like both anode and cathode observation. Alrighty, everybody. Okay, so next one. At the end of the experiment, what changes take place at the silver nitrate solution? Okay, again, nothing changed. Color, no change. Must specifically mention color. This is a bit different. Okay, so you can write the color of what's the name again? The color of silver nitrate solution does not change or remain unchanged. Okay, can. So you can write the color of silver nitrate solution remains unchanged. Okay, nice. I think we have time for one more. Battery, we do simple cell like this one. Simple cell, this topic. You use metal to create electrical energy to create simple cell. Can I go to section B if I have this? Is this the one? Is this the one? No, I don't want. 36, everybody, 36, question 15. 36. Okay, how would you know if it's a dry cell question compared to electrolysis? First, most important is no battery liao. You are creating your own battery now. This is a battery. So replace with a light bulb or something else, but it's not battery or not dry cell. And you realize it's all metals now. It's not like what one side copper lah, then one side what spoon lah. No, it's both metals. Okay, so mark the electron flow by using arrow. Okay, rules and regulation. Between these two metals, one must be more reactive than the other one. If you all know the sequence in your head already, please stop calling me a zebra. That thing, you should already know zinc is more reactive than copper, rather than guessing. You know, your friend is still struggling. Like, oh, what is this? Which one more? You already know zinc is more reactive. So rules and regulation, my friends. The one that is more reactive should be your negative terminal. Must be. It's like that one. Like that. Okay, fixed. Please remember that. So there's no left and right. Do you realize, why copper positive on the left side? No, not always positive on the right side, like cathode and not, no, not, it could be the other way around also. Sometimes zinc could be on the left, positive could be on the right, because by right, from what we learn as our syllabus, people will prefer the more reactive one on the left side. They do it this way. Zinc is on the left, copper is on the right. That doesn't matter actually. Doesn't matter. As long as you have the correct positive and negative terminal, then can now. So to draw the electron, remember, more reactive will release to the less reactive. More reactive release to the less reactive. That means zinc will release to copper. More powerful people, more higher level people are people tends to give and provide. Lousy people are the one who always take out their hand and take, doesn't provide. You get what I mean? You know, so it should be from zinc to copper. So this is what you draw. So arrow goes up, electron, 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 electron. There you go. Zinc to copper plate. More reactive will give out, less reactive will take. That's the rules and regulation. You draw it, then don't need to write anything. The line, no need. Name the plate that functions at cathode. Now you know, no? Cathode is what? Cathode is negative, ma? Who is negative? Easy cheesy. Okay, right. Next one, shall we? Okay, so like next one, what is the function of hydrochloric acid? Okay, this thing here is what we call electrolyte, right? What we used to learn is copper sulfate solution. This is what we call a salt solution. So salt solution also can, acid also can. Some more, sometimes questions want to be like, macam yes, macam hot question. They put this into like a lemon. I'm not sure you've seen that before. That's fine, that's fine. Because it's acid, lemon is acid. Or a vinegar also can. So as long as acid or salt solution, like what we had in the front part just now was copper sulfate solution, that's okay. So what is represent, what's the function of hydrochloric acid? No matter salt, copper sulfate solution, or this one, acid, hydrochloric acid, they are all act as electrolyte. Okay, act as electrolyte. Okay, no problem. All right, next one. Name another solution, right? Has the same function as you mentioned. Okay, then we use this one. Copper sulfate solution. You always go for this few kinds lah. Copper sulfate solution, hydrochloric acid. Now we all stick to salt solution or acidic solution. So all these are what we call a salt solution lah. Okay. Can copper sulfate solution. Right, next one. Energy change. Okay, we are actually using metals and acids and all this to create electrical. So of course the end point is to produce electrical energy. But what we're doing now, what energy we're having now with the metals and the acids, that is starting off with chemical, right? So chemical energy, arrow, we are producing electrical. Okay, there you go, easy cheesy. Chemical energy goes to electrical energy. Okay, question E, everybody. Now, which one will produce a larger current? Remember this, larger current means the metal must have very high potential difference. Okay, how do I show a very capable person compared to another lousy person? The more they are different to each other, the easier I identify. That means if I have both also almost capable person together, I wouldn't be able to tell who is better. But if I have someone that is super capable and the other person is just shitty person, okay, then I will know, oh, the difference is very big. But when I have two very similar person, very capable or very shitty, I couldn't differentiate. You understand? So in order to have a very high voltage or big current, I must have a very different type of metal. Both are very different in reactivity. So remember the list that we all can only choose is from magnesium to copper. Nothing above, nothing below. Why? Because above metal too crazy already, we cannot use. They will explode one. The two metals below too expensive already, no money. So we can only choose between these. Don't go further. Okay, so the best if you could go magnesium and copper. One side magnesium, one side copper. Wow, I tell you this is the voltage is very big one. Okay, it's gonna be very high voltage. If you have zinc and iron so near, like just one step over, very low voltage. If you have zinc and zinc, same, zero voltage. Okay, the closer you are, the lesser to zero. So, do you remember your metal list? Imagine in exam, you cannot copy ma, they have to, oh, you die lo, copper, magnesium, copper and magnesium. Okay, copper is lower. Okay, copper and iron, copper and iron very close there. See, it's going to be difficult sometimes if you don't remember the sequence. You kind of need it in certain questions. So, but for now, copper and magnesium is the furthest we can have. Okay, so this should be the largest current. All good? Okay, then I have like all the batteries and dry cell continue. You can actually try out yourself. See if you understand what I teach today. This chapter a bit heavy. Okay, cool beans, everybody. We are done for the night.